This is the last part of the review on Chapter 2. 2.7 was all about inverses. These directions say find the inverse, use inverse function notation, and then name the domain and range of the original function and its inverse. A word about that. Remember, once you have found the domain of the original, it is exactly the same as the range of the inverse. So just find the domain of the original, automatically it's the range of the inverse. Also, when you find the range of the original, it is equal to the domain of the inverse. So going back to find the inverse, our first step is to put y in place of f of x. Then when you find the inverse of a function, it's just a matter of swapping your x and your y. So x comes over here, y comes over here, and that is the inverse. However, it's not in the right form. We need to solve this for y. To solve this for y, we undo the square root, which tells us to square both sides, which gives me y plus 4 here, because the square root of something squared is just the something, and this is x squared. Solve this for y by subtracting 4 from both sides, and we get y equals x squared minus 4. Now, this is only valid for x being greater than or equal to 0. And the reason we know this is because this right here, the square root function looks something like this. So that when you do the inverse of that right there, it's only going to give you this half over here. It will only give you half of the parabola, not the whole parabola. Now the inverse function notation, I should start it with this equals x squared minus 4 for x greater than or equal to 0. Now the domain of the original, that is a square root function. To find the domain of a square root function, we take what's inside and we set that greater than or equal to 0, which gives me x greater than or equal to negative 4. In interval notation, that is negative 4 to infinity, which means automatically the range of the inverse is negative 4 to infinity. No thinking required. The range of this function, here's our function right here, the range, the lowest y value is 0. So the range of the original is 0 to infinity. Therefore, the domain of the inverse is the same thing. It is 0 to infinity. Same steps over here. Put y in place of g of x. It's the cube root of x minus 4. To do the inverse, swap out your x and your y. And then we want to solve this for y. To undo cube root, we do the opposite, which is cube both sides. So this is x cubed equals y minus 4, because cube root and cube cancel each other out, and you're left with the y minus 4. Add 4 to both sides will give me x cubed plus 4. So in function notation, it is this. And the reason I don't need to put this extra restriction is that this was cube root. So now the domain of the original, the domain of a cube root function, is the infinities. So the range of that is the infinities. Also, the range of the original is the infinities. Therefore, the domain of the inverse will be the infinities. You can prove this to yourself by looking at this on a graph with your calculator. So the cube root of x minus 4 looks something like this. And then x cubed plus 4 looks something like this. And if you look at those, first off, they do look like inverses. Remember, the inverse is the idea that they are a reflection across a line y equals x. But also, we're just talking domain and range right here. This goes forever to the left, forever to the right. That's why the domain is this. And up and down, same thing with the inverses. So you can use your calculator to help you out with the inverse. Find the distance and midpoint. Here are the formulas for distance and midpoint. You do need to memorize those. And then it's just a matter of stuffing in and doing the arithmetic. So the distance for this first one will be the square root of the difference between the x's. So that's 3 minus negative 1 squared, plus the difference between the y's, 9 minus 8 squared. You can type all that squared stuff in the parentheses in your calculator if you need to, but minus and minus is plus, so that's 4 plus 1, 3 plus 1 is 4 squared. 9 minus 8 is 1 squared. So this is 16 plus 1, which is the square root of 17. Now, with the square roots, you're going to be asked to put them in simplified radical form. Square root of 17 is as simplified as possible, but it's possible that you may have to do a factor tree on this. Midpoint is a matter of the average of the x's and y's. So there's 2 on the bottom here, x1 plus x2, 3 plus negative 1, and 9 plus 8. 3 plus negative 1 is 2 over 2. 9 plus 8 is 17 over 2. And you can simplify this out. 2 over 2 is 1. You can leave the 17 over 2 as the fraction 17 over 2, or you can change it to the decimal 8.5. So same thing with these points. I'm not going to rewrite the formula. We'll just look over here. The distance is the square root of the difference between the x's. So 2 minus 5 squared, or 5 minus 2 squared, it doesn't matter. And then 7 minus 11 squared. You can type all of this part directly in your calculator with the parentheses and the squares if you want. But if you're going to do that, don't enter the square root, because if it comes out to be a non-perfect square, you'll get a decimal there, and that's not what I want. 2 minus 5 is negative 3. Quantity squared is positive 9. 7 minus 11 is negative 4. Squared is positive 16. 9 plus 16 is 25. The square root of 25 is 5. So it's entirely possible that your distance will come out to be in integers. And then your midpoint is just a matter of doing the average of these. 2 plus 5 over 2. 7 plus 11 over 2. 2 plus 5 is 7 over 2, which does not simplify unless you want to write it as a decimal. 7 plus 11 is 18 over 2, which gives us the whole number 9. In section 2.8, we also looked at circles. And before you can name the center and radius of a circle, you must complete the square. Remember, the steps for completing the square are to get your x's together, put plus blank there, because we're going to add something in a minute, plus y squared plus 8y plus blank, because we're going to add something there in a minute, and then move the 12 to the other side, makes this a positive 12. What goes in the blank is what completes the square. To find out what that number is, we take half of the middle. Half of 6 is 3, squared is 9. Be sure you add it to the other side. Same steps here. Half of 8 is 4, squared is 16. Add it to the other side. The reason to complete the square is so that we can get it into this format, which is the general form, which is the standard form for a circle. So this is x minus 3 squared, and this is y plus 4 squared. This is minus because that's minus. This one is plus because that one's plus. Do your arithmetic over here is 37. And then you can name your center as 3 comma negative 4. Remember, you are going to change the sign. That was x minus 3, so this is 3. That was plus 4, so it's negative 4. Your radius is the square root of that number over here, which is the square root of 37. Sometimes the radius comes out to be nice and neat, sometimes not. On your calculator, type in the square root of 37, and it's approximately 6.1. So I'll just kind of fake this graph here. The center is 3, negative 4, so go over 3, go down 1, 2, 3, 4, and then count 6 in every direction. So 1, 2, 3, 4, 5, 6 and a little bit. I really can't get that little bit on here very well. Over 1, 2, 3, 4, 5, 6 and a bit. I'm going to go off the graph down here. 1, 2, 3, 4, somewhere around here. 1, 2, 3, 1, 2, 3, 4, 5, maybe about here. And there's just no way I'm going to get a circle to look right here. But it's something like that. Same steps over here. Let's get x squared minus 10x plus blank plus y squared plus 12y plus blank. Move the 40 to the other side, and it's a negative 40. Do your steps for completing the square. Half of 10 is 5, square root is 25. Add that to this side. Half of 12 is 6, square root is 36. Add that to this side. Factor it up. X minus 5 squared, y plus 6 squared. Do your arithmetic here, and this is 21. So our center is 5, negative 6, and the radius is the square root of 21, which is somewhere around 4.6. To graph this, count over 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6, and I'm way off the graph. And then count a little about 4.5 in every direction. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 and a bit, and I'm off the graph down here. So this is going to look funny, but it looks funny anyway.